Hi everyone, and welcome to my channel, which is going to cover the IGCSE computer science content. My name is Zareen, and for this video, we're going to be looking at all the conversions that you need to know, and there are exactly 6 of them. So we're going to cover all of them in this video. And just so you know, we can't use calculators in the computer science papers for IG, so I'm going to teach you how to do all of these conversions without a calculator. So before we start, you're probably wondering what we're even converting between. So we're converting between these 3 number systems, okay? So denary is the base 10 number system, and that's the most commonly used one that we use all the time. Like when we say our age, we say it in the base 10 number system. And binary, it's the base 2 number system, which uses zeros and ones. And you have to know that computers, they're made of switches, right? And these switches, they can either be turned on or off. So they can either be 1 or 0. So that's how binary works. And we're also going to be looking at hexadecimal later in this chapter. But just know that sometimes the ones and zeros in binary, they get very confusing. That's when hexadecimal comes in. And also know that for hexadecimal, from like 10 and above, like from 10 to 16, because it's base 16, it doesn't use numbers anymore. It uses letters from A to F, okay? So let's get straight into the conversion. So the first thing we're going to do is we're going to convert from binary to denary. And the only thing that you have to know is your powers of 2, because it's base 2, right? So you have to know the powers of 2 from 2 raised to the power 0, which is 1. Anything raised to the power 0 is 1. And then 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, up to 2 raised to the power 7, which is 1 to 8. You have to know all of this. This is a must. So before we continue, just know all the numbers, the 2 raised to the power, all of those numbers. Okay, so let's start by writing a binary number, any binary number. So it just consists of zeros and ones, right? So let's just put random zeros and ones and see what we get. So right now what I have over here is a binary number because it consists of zeros and ones. And you know how I told you that they're like switches that can either be on or off? So the 0 means the switch is off. So since this is 0, we're not going to write the 1 to 8, okay? But this is 1. So that means the switch is on, and right above it we have 64, which is 2 raised to the power 6, and we're going to write it down. So these are zeros, the switches are off, we're not going to write this. But these, they're ones, so we're going to add 4 and 2. So what we have to do is basically anything that's 1, anything that's turned on, we're going to write the values down. So 64, 4, and 2. And this is very simple addition. You don't even need a calculator for this. You're going to get 70. So that's basically it. That's all you have to know to convert from binary to denary. Your powers of 2 up to 7. Okay, so just so we're clear, let's do like another example. Okay, so this time let's add a lot of ones. Okay, like all of these, let's make them ones. Okay, so instead of adding all of these, there's actually a shortcut which I'm gonna let you know. Okay, so let's look at this. This is 4, right? So if 2 and 1 are on, we're gonna get 3, and this is 4. Okay, and this is 8. And if 4 and 2 and 1 are on, we're going to get 7. I hope you understand what I'm doing. So over here, we have 1 to 8, right? So if all these are 1s, we're going to get 1 minus 1 to 8. We're going to get 1 to 7. Just like over here is 4. And if these 2 are on, we're going to get 3. And over here is 8. And if these 3 are 1, we're going to get 7. This is 1 to 8. So all of these are going to add up to 1 to 7, right? But this is, wait, why did the eraser come from? This was 1 and 0, right? So this is 0. So we're going to get 1 to 7 minus 1, which is 1 to 6. But just to make sure, let's actually do the addition, okay? So we have 64 plus 32 plus 16 plus 8 plus 4 plus 2. These are a lot of numbers, but I think we can add them. So we have 64 plus 16, which is going to be 80. And we have 32 plus 8, which is going to be 40. And we have 4 plus 2, which is 6. And it gives you 1 to 6. So it proves that if this is 1 to 8, then all these numbers are going to be 1 to 7. Okay, so if every single switch is on, we're gonna get 255 because 2 raised to the power 8 is 256. Okay, so I hope you get that. Okay, so let's move on to the opposite, which is converting from denary to binary. So let's take any denary number that we want. Okay, I'm gonna take 75 and write it right here. And I'm gonna put a 2 and an R here. So you're probably wondering what the R is for. The R is for a remainder. So we're gonna divide 75 by 2 and write down the remainders. That is it for converting from denary to binary. We're gonna divide by 2, okay? So how many times does 2 go into 75? It goes your 37 times, remainder 1. And then 2 goes, so short division. You have to be really good in your short division. 8 times, remainder 1. 2 goes into 18 9 times with a remainder of 0. 2 goes into 9 4 times with a remainder of 1. 2 goes into 4 twice with a remainder of 0. 2 goes into 2 once with a remainder of 0. And 2 goes into 1 0 times with a remainder of 1. And you see all the remainders are either 1s or 0s. All the remainders are either 1s or 0s, so that is it. That is our binary number. But we're not going to write from the top downwards. We're actually going to write from the bottom upwards. So the binary value of 75 is 1001011. Okay? So imagine your age was 75, right? In binary, this is your age. But there's actually another way to do it, and I actually prefer that way. So let me show you the other way to do this. Okay, so let me erase this real quick. Yeah. Wait, let me just go back. Okay, so we're trying to get 75, right? So we're going to build up to 75. So if the switch for 1 to 8 is on, we're going to get a number that's like 1 to 8 or higher, but we don't want that, so that switch is going to be off. But 64 is less than 75, so that switch is going to be on. But if we on both 65 and 64, and 32, we're going to get 90 something. We don't want that. And if we add 64 plus this, we're going to get like 80. We also don't want 80, we want 75. So 64 plus 8, yeah, that's good. That's going to give us like 72. 72 plus 4 is going to be 76. That's too much. So no, that's off. But 72 plus 2 is 74, plus 1 is 75. So yeah, we have the binary. So let's check whether the binary are the same. Well, you probably think they're not the same because this starts with a 1 and this starts with a 0. But let's count the number of bits, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8 bits. 1, 2, 3, 4, 5, 6, 7 bits. So if we just put a 0 over here, it's going to be 8 bits and it's going to be exactly the same. So now I hope you understand how to convert from binary to denary and denary to binary. It's very straightforward. Okay, so let's move on to the next part, which is the binary and hexadecimal part. And in my opinion, this is like the easiest part, but we have to learn a few new things, which is so from denary, you see after 9, when it becomes double digits, like 10 to 15, we have hex values, okay? They're going to be letters and not numbers. So after 9, we're going to have A, B, C, D up to F for 10 to 15. So I hope you have that in mind, okay? So you just need to know that, so let's move on. So for converting from binary to hexadecimal, you see how every binary digit is like 4s and 4s. That's what we're going to do. We're going to separate everything into 4s, okay? So we're gonna take 4 binary numbers and we're gonna separate them. And then you can either like memorize the table somehow, but I'm not gonna say that. Like if you look at the table right now and you look for 1110, you're gonna get E, right? But what if you don't have the table? We're gonna figure out ourselves, okay? So we have 1110, but remember our 2 raised to the powers. So we know that 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, and 2 raised to the power 3 is 8. So anything that's 1, we're going to add them. So we're going to have 8 plus 4 plus 2, which is 14. And this, you have to know. You have to know that 14 is equal to E. So that's E. That is it, basically. That's all you have to do. So let's do it for this. So we know that this is E. Over here, we know that this is 0, and this is 2, and this is 4. So we have 2 and 4, and when you add 2 and 4, you're going to get 6, right? And over here is just 1. So that is literally a 16E. So the binary, all these binary and hexadecimal is just 16E. Okay, and for hexadecimal to binary, we're going to do the complete opposite thing. So we have A, we have F, we have 3, we have 0. What we're going to do is we're going to convert them to the denary form first. So we're going to make this, we know that A is 10, we have to know that. And you know that F is 15, and 3 and 0 are just, numbers. So we're just going to keep them like this. So we're going to write them. Let's do the 1, 2, 4, and 8. So for 10, we need 8 and 2. These are zeros, okay? For 15, this one is just direct. Just know that it's 1, 1, 1, 1, okay? That one, we don't have to go through all the stress. And for 3, you have 1, 2, 4, and 8. So we're going to have 2 and 1 making 3. And 0 is just zeros throughout. So we're going to write them all together. So 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0. So if this hexadecimal was supposed to be a binary number, this is what it would be. Okay? So let's move on to the final part, the last two, which is from hexadecimal and denary, converting between them. So for hexadecimal to denary, you need to know the powers of 16, just like you needed to know the powers of 2, you need to know the powers of 16. And I don't think you need this. I don't think they'll give you a number that much high up. Well, hopefully they don't. So you just have to know these 4. I think that's very important, okay? So let's write a random hexadecimal number, okay? Let's add letters like A, and let's do smaller numbers like 1 to 7, okay? And you see A is hexadecimal, but we know that is actually 10. So all you have to do is multiply, okay? So we're going to multiply the 10 with the 16 raised to the power 3, which is 40960. We're going to multiply 1 by 16 raised to the power 2, which is 256. 16 times 2 is 32 plus 7. Yeah. So that's it. We're going to add all of them. So for converting from hexadecimal to denary, we're going to multiply the hexadecimal we have with the powers of 16, and then we're going to add them. So when we're adding them, I think we should be really careful, because one small mistake is going to cost you a lot. And they give you really big spaces to work out. And we can use that space to actually work out and not make mistakes, because this is the simple part. And if you start making mistakes over here, you shouldn't risk that at all. So this is going to be 5, carry 1. You're going to have 5, 6, 12, 13, 14, 15 again. Okay, and you have 12. You're going to carry the 1, and you're going to have 4. So yeah, so hexadecimal A127 to denary is 41255. That is it. Okay, and let's move on to the last part, which is from denary to hexadecimal. And let's just clean this part of workout. Okay, so this part is going to be really simple if you know your 16 times table. Just if you want your life to be easy, just know your 16 times table, okay? Okay, so let's pick a random denary number. What did we pick last time? I think 75. Let's take a bigger number. Let's take something in the thousands, like 1506. Okay, so we're going to convert from denary to hexadecimal. Remember last time, from denary to binary, we divided by 2. So guess what? We're divided by 16. That is literally it. We're going to divide 1506 by 16 and write the remainders. exactly like last time. There's no difference. Okay, so 16, so this is where you need your 16 times table. It really helps you. So we know that 16 goes here 9 times, which is 144, and then you have a remainder of 66, and then 16 goes into 66 like 4 times, yeah, with a remainder of 2. Okay, now 16 goes into 94 5 times, that's 80 with a remainder of 14, and 16 goes into 5 times, like 16 goes into 5 0 times with a remainder of 5. So short division is really important. And remember, we're writing from bottom upward, so we have 5, 14, 2. But remember, in hex we don't have 2-digit numbers, we have letters. And if 15 is F, then 14 is E, right? So we have 5 E2, and that is it. This is basically all you have to do to convert from denary to hexadecimal, and I hope you realize that it's quite similar to the denary to binary. Like, this is, all of them are really similar, and they're really simple, and that's the first part of the syllabus covered. So thank you so much for watching.